Well, hello everyone and welcome back to our videos on the topic of molecular genetics. So in the last video, we stopped at this slide where we were trying to look at how a gene codes for a polypeptide. And we saw that the order of nucleotides on the gene determines the order of the amino acids in the polypeptide. So you might imagine that, let's say the gene has a sequence like A, T, G, and C. How does this code for a polypeptide? You might imagine a decoder that works a bit like this. That if the nucleotide is A, it codes for amino acid type 1. So if there's A here, then the first amino acid in the polypeptide will be the type 1 amino acid. And then if there's T, then the next amino acid would be type 2 amino acid. And then if there's G, the next one would be type 4 amino acid, and then finally type 3 amino acid. So from this 4 nucleotide sequence, I get a 4 amino acid polypeptide. However, there is a problem with this sort of code. And here's the problem. There are only 4 types of nucleotides, A, T, C, and G. However, there are 20 types of amino acids. So there are not enough nucleotides to match the number of amino acids. And that's a problem that people thought about, and so they knew that the sort of decoder, this sort of simple decoder, where one nucleotide codes for one amino acid does not work. So if this doesn't work, then what does? Well, after thinking about it for some time and performing some experiments, scientists came to the conclusion that the sort of decoder is not that one nucleotide leads to one amino acid, but rather 3 nucleotides code for one amino acid. So the genetic code is actually a triplet code. So how would this genetic code, this triplet code, work? Well, I want you to imagine that there's a gene with this sequence, okay? ATG, GTA, CTC, ATA. Let's imagine there's a gene of this sequence. Now the nucleotide in the gene can be grouped into triplets, into trees, and every triplet is called a codon. So this is codon number 1, and then there's another codon here, and then another codon here, and another codon here. And how the genetic code works is that each codon will code for a specific amino acid. So ATG would code for amino acid called methionine. So the first amino acid in the polypeptide will be methionine, right? Followed by GTA. GTA codes for valine. Followed by CTC, which codes for leucine. Followed by ATA, which codes for isoleucine. So from this sequence of 12 nucleotides, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I end up with a polypeptide of 4 amino acids. So it's 3 nucleotides coding for 1 amino acid, 1 codon coding for 1 amino acid. So what is the genetic code? Well, it is a set of rules that states which amino acid each codon codes for. So you can see this genetic code here, and we can actually use this to decode our gene into amino acids. So let's say, I can take a look at it. So if I see the codon CAG, that codon would code for this particular amino acid. Then CAA would code for this particular amino acid. And then you can see that all these codons here code for this particular amino acid. So because we're using a triplet code, there are actually 64 possible codons. So you can see that here, 1, 2, 3, 4 times 16. So that's 64 possible codons. And remember, we had 20 amino acids. So an interesting fact is that there's actually more than 1 codon per amino acid. So you can see that, for example, valine, right? It's coded by 4 possible codons. And you will learn more about this in JC. But that's why we say that the genetic code is, there's a special word for it, which is not in your syllabus, just for your information. The genetic code is degenerate. There's more than 1 codon per amino acid. And that's quite helpful sometimes, because imagine if originally your gene sequence was, let's say CAA, right? And let's say there's a genetic mutation, right? Something happens to this A and changes it into a G. So from CAA, the gene becomes CAG. Well, in this case, the mutation would not affect the amino acid that is coded for. So the mutation ends up being it's not actually a mutation that affects the polypeptide being formed. So this mutation is kind of like a silent mutation. So it's good for your genetic code to be degenerate. It's good that there's more than one codon that codes for each amino acid, so that if there's any mutations by accident, right, it might not always affect the polypeptide that is formed. Now, just one final note, your textbook and syllabus use this term genetic code a bit differently. Genetic code, I've already defined it. It refers to that set of rules by which you can actually match the codon to an amino acid. However, your textbook uses the phrase genetic code in this way. It says that the message stored by a gene is known as the genetic code. And your syllabus states that DNA is used to carry the genetic code, which is used to synthesize specific polypeptides. So I think in this case, if we stick to your textbook and your syllabus, so to be safe, if you stick to your textbook and syllabus, the phrase genetic code kind of means genetic information, right? So if I put this sentence up to you again, it would be that DNA is used to carry genetic information, which can be used to synthesize the polypeptides, right? Okay, I'm going to stop the video here, and actually here is where you need to know up to for your syllabus. Now the next video is a bit of extra. If you're interested, you can go further. We're going to explore how the nucleotides in your gene, what is the process that actually causes those nucleotides to be read, to be interpreted, and to be used to synthesize a polypeptide.